Alright, in this video we're going to pick up from where we left off in the last video. In the last video we looked at how to determine what the coordinates are going to be, and we looked at rotating a single point. In this video we're going to rotate an entire graph. So here we have example 1b, convert the equation 21x squared plus 10xy times the square root of 3 plus 31y squared equals 144. To an equation involving x prime and y prime, so an equation on our new rotated axes. So if we take a look at what the graph of this equation looks like, it's an ellipse that's been rotated. So, and the rotation aspect happens because of this xy term, this 10xy times the square root of 3. And in the next video, we're going to take a look at how to determine how many degrees or radians the original conic section rotated. But for right now, we just want to rewrite this ellipse in terms of x prime and y prime, where from the x prime and y prime axis perspective, it's not rotated at all. I am going to warn you that this video is pretty algebra intensive, so there's a lot of keeping track of things and keeping organized with things, so you might want to watch this one after a good night's rest. So first up, our x coordinate for our original is x prime times the cosine of pi over 3, because again we're rotating pi over 3 from example 1a, minus y prime times the sine of pi over 3. So cosine of pi over 3 is a half, sine of pi over 3 is radical 3 over 2, so we have x is going to equal 1/2 x prime minus radical 3 over 2 times y prime. Now we want to do 21x squared, so we're going to start by squaring this, and when you multiply this out, and I encourage you to multiply this out manually, you'll get x prime squared over 4 minus x prime y prime times the square root of 3 all over 2 plus 3y prime squared over 4. Again, that's just multiplying 1/2 x prime minus square root of 3 over 2 y prime times the whole thing squared. Then we're going to multiply by 21, so we're going to take each of these terms, multiply them by 21, and we'll get 21, and 21, and 3 times 21 is 63. So again, the tricky part is the algebra involved in getting this line by making sure you're really careful with your multiplication in squaring this right-hand side in red. All right, so that's the 21x squared aspect of it, and I'm just breaking this down into each of these three parts on the left side here. For y, our y coordinate is x prime times the sine of pi over 3 plus y prime times the cosine of pi over 3. Again, the angle of rotation from example 1a was pi over 3. So with sine of pi over 3 and cosine of pi over 3, we got square root of 3 over 2, and cosine of pi over 3 is a half. So we're going to square that result, and again, be careful with your algebra here. When we square this right-hand side, we get 3 times x prime squared over 4 plus x prime y prime times the square root of 3 all over 2 plus y prime squared over 4. And then we're going to multiply that y squared by the 31 that's in front of it. So when we multiply everything on the right-hand side by 31, this is what we get. Now the xy in the middle here, the 10xy times the square root of 3, x times y, when we multiply this out, we get x prime squared times the square root of 3 over 4 minus x prime y prime over 2 minus y prime squared times the square root of 3 over 4. Then we're going to multiply that xy by 10 times the square root of 3. So 10 times the square root of 3 times this first term gives us 30 x prime squared over 4. 10 square root of 3 times the second term gives us 10 x prime y prime square root of 3 over 2, and 10 square root of 3 times this last term gives us 30 y prime squared over 4. And I'm not going to reduce any of these fractions simply because I want to be able to combine like terms a lot easier with what we got for the 21x squared slide, what we got for the 31y squared slide, and this one here as well. All right, so substituted in the values that we got for 21x squared for the first slide, 31y squared for the second slide, and 10xy squared root of 3 for this previous slide. Here's our 21x squared slide. We're going to add to that the 10xy square root of 3 slide. And then we're going to add to that the 31y squared slide. So again, it's a lot of algebra to keep track of. Very easy to make a calculation error, so you please be careful. But when we add these up, 21 fourths, 30 fourths, 93 fourths, we end up with 144 over 4, which is 36 x prime squared. The negative 21 square root of 3 over 2, negative 10 square root of 3 over 2, and 31 square root of 3 over 2, these middle terms disappear completely. So notice now that we do not have any x prime y prime terms. We've eliminated that x prime y prime term. For our y prime squared, we have 63 fourths, negative 30 fourths, and 31 fourths ends up with 64 fourths, which is 16 y prime squared. And bringing down the 144 that's on the right hand side, we have 36 x prime squared plus 16 y prime squared equals 144. And now if we divide everything on both sides by 144, we get x prime squared over 4, 36 over 144 is 1/4, plus y prime squared over 9, 16 over 144 is 1 over 9, equals 1. And so this is what our ellipse looks like in the x prime y prime coordinate plane, where here it would be where we're looking at the original x and y axis. I'm using that as the x prime y prime. But notice from the x prime y prime perspective, it's a tall ellipse. And in the next video, we're going to take a look at how to determine how many degrees or how many radians it rotated to get our original picture, which we have in this case in black. So, all right, that about does it for this video. I will see you next time.